In this one video, we're gonna take you through all 4 of the most common gas valve assemblies, and we're gonna teach you exactly how to diagnose, do I need a new thermocouple or do I need a new control valve? This video's about ready to get lit. Unfortunately, most plumbers walk up to a water heater and they'll say, well, it probably needs a thermocouple, maybe a control valve, and they just start throwing parts at it until things work again. And they never really understand what fixed it. If you're a plumber and you're learning from this video, you sound 10 times more professional to the customer when you're willing to break out a multimeter and start measuring for fractions of a volt on a gas water heater. A water heater that isn't even connected to electricity. If you want to be a good, upstanding professional plumber, you need to be learning this stuff right here. We really have 4 different control valves. You have a series 100, this is a series 100, and this is a series 100. This one's a series 200. Notice the 2 wires coming out of the end of it. We have a series 300 and 400. The only difference is a series 300 has a short shank and a series 400 has a long shank. So this here is a burner assembly for a series 100 gas valve, and this is a burner assembly for a series 200 gas valve. We've built this rudimentary stand. The stand has a 3/4 inch threaded connection at the top, which is the size of these threaded shanks are on the back of the control valve. We hang the burner assembly off of it. We've lit the pilot, and now we can turn on the burner assembly and run it just like a normal water heater would, only now we're up and out and accessible so we can show you exactly how to diagnose every little piece of these assemblies. One of the things you will need for this test is a digital multimeter. Now, I'm a big fan of the UEI DL369. These things are not wildly expensive. They're not overly complicated either. They do just enough for everything that you're going to encounter in the plumbing world. It even has an amp clamps so you can test electric water heaters. This has all the features you're going to need to test your gas water heaters. So the tank assembly would be like right here. This gas control valve screws into the tank. This probe is gathering the temperature of the water, and then all of our controls actually come down here to what would be the bottom of the tank. There's a big dome inside there. Since we have a burner, we need that burner to do a couple of things. We need it to operate automatically. When the water gets cold, the burner comes on. When the water gets hot, the burner turns off. Then also, we need it to be safe. If the pilot light were to blow out, we don't want this assembly spewing gas everywhere inside the home or in the water heater, because that could create an explosion. These gas control valves, they have 3 devices coming off the bottom of them. They have a thermocouple, they have a pilot tube, and then they have a main burner gas supply line. We are going to really focus on the thermocouple today. The thermocouple is the electrical safety device that keeps your house from blowing up. It gives the gas control valve the signals that it needs. A thermocouple is going to create anywhere from 15 to 30 millivolts. And then we're going to run that electricity through this device, and it's got to go through a couple of sensors before it actually tells the device to operate. In the meantime, I do want you to notice the difference from one temperature probe to the other. This one came out of a heater that was from the early 80s. It has the same plastic protective wrap around the temperature probe. However, this one's covered in scale. And it was actually covered in so much scale that we scraped most of it off when we were pulling it out of the old water heater. Scale in water is a wonderful insulator. If we get too much scale wrapped around this temperature probe, then the water heater is going to be very delayed. The water is going to have to get extra cool before the temperature makes it through the scale and signals to heat the water. Then the water heater actually has to get extra hot before that temperature makes it through the scale and tells this guy to shut off. One of the signs of an aging water heater is that you start experiencing some more wild temperature swings. We should just be able to pop these screws off. They've been on there for 40 years. These are just Phillips screws, but on your newer heaters, you might have Torx screws or some more tamper-resistant type of screw. This comes off. So what we have inside here is 2 things. We have a temperature probe, which is actually still in there, and that temperature probe pushes on the back of the control valve here. This is how you actually set your temperature of the unit. The temperature settings are a little vague, but they're still fairly close. And basically there's a sprung piece of metal inside this unit that will click on and off as the temperature is either satisfied or unsatisfied. If we're too cool, it'll click on, and then once we achieve the desired set point, it'll click off. We also have inside this temp probe, these wires were going inside there. Here's what this valve looks like without the temp probe on there. You see some wires over here that are tucking away and going into the temp probe. So these wires run down there, and there is a little thermistor attached to these wires. This little thermistor is a one-time use safety. And what it does is if the water were ever to get too hot, for instance, maybe this gas valve broke and stuck in the on position, and it was just baking and baking and baking and baking. If the water ever got too warm, this thermistor will blow. The gas valve is now ruined, but that safety device just saved you from possibly getting scalded from water that was way, way too hot. On your multimeter, you will have some wavy lines. You see here we got a wavy line and a wavy line. A wavy line would indicate alternating current. We want direct current, so we're gonna hit this select button. And now that we've hit that select button, we now have straight lines. So now we're able to measure voltage. We've got our multimeter turned to the V for voltage, and you see it's either got a straight line or a wavy line, and we are on the straight line setting. So that is going to be direct current. These thermocouples produce DC energy, direct current. So we're going to take our black lead and we're going to ground it on one of the assembly screws of the control valve on the front. And then our red lead, we're going to make contact on the lower wire coming out of the unit, and we're going to make contact on the upper wire coming out of the unit. Depending on the signal that's coming out of these wires is going to tell us, do we have a bad control valve or do we have a bad thermocouple? If we don't get at least 10 millivolts on one of these spade terminals on the back of the control valve, then we have a bad thermocouple. The bottom lead is telling me how much energy the thermocouple is creating, and the top lead is telling me how much energy is left over after that energy goes through the thermistor that's down in the temp probe. This thermistor consumes a little bit of energy. According to this test here, we've got 9.5 millivolts running to the thermistor. The thermistor is consuming about 2.5 millivolts, and then we're left with about 7 millivolts to run the control valve. Some control valves don't actually have the little metal spades for you to contact. Some control valves, it is just raw wires coming out of the unit, and so you'll actually need to take the sharper pointy ends of your leads and actually poke it through the insulation to get the reading you're looking for. This control valve from the 80s, there is no metal spades coming out of it, and so we would have to poke our leads through those wires. The thermocouple without a load under it will produce about 30 millivolts. The moment we connect that thermocouple to the control valve, we're now putting it under a load. And when we put it under a load, what we're gonna see 10 to 14 millivolts under load. What we're actually looking for on the other spade terminal that's coming out of the control valve is we're looking for 6 millivolts or more going into the control valve. 30 millivolts with no load, 10 to 14 millivolts under load, and then we want to see about a 4 millivolt drop, leaving us at least 6 millivolts to run the gas control valve. So we have a plunger inside the gas control valve. This is actually what opens up and lets the gas flow into the unit. We have to manually open the plunger by pushing this button down whenever we light the heater. And then once you get the heater lit, and you have to keep it lit for about 30 seconds, what you're doing in that 30 seconds is you're letting the thermocouple warm up and start producing electricity. And then that 6+ millivolts that are left over is actually going into a small electromagnet that's held around this plunger, and it's holding the plunger up for you once you let go of the button. Right now we don't have anything connected to anything, so if I let go of the button, the plunger closes. The one that we have on our bench test, we've held the plunger down, we've lit the pilot, and now the electromagnet is holding the plunger open. So I'm gonna put my leads on here, and then we're gonna blow the pilot out. All right, so we've blown the pilot out, and we're actually gonna watch the millivolts start to drop as that thermocouple cools off. You're gonna hear a click, and that click is literally the gas valve closing the moment that electromagnet no longer has enough energy to hold the plunger up. There it goes. Before we can make a proper diagnosis on a control valve, we have to have a good thermocouple in play. 10 to 14 millivolts under load. Currently, the one on our bench test is doing 9.5, so we already know our thermocouple is bad. TC for thermocouple. If we have 10 to 14 here, but we don't have 6 on the other spade terminal, then we need a new control valve. My theory is if we're ever replacing a control valve, we also replace the thermocouple. Thermocouples are not very expensive at all. They sell them in various different lengths. I always suggest you buy a longer one just because you can coil up the extra and no big deal, but you can't stretch one that's too short. Let's add one extra little safety and move on to the Series 200 control valve. The biggest differences that you'll notice, the two long red wires that are coming out of the Series 200, but also a Series 100 control valve is of the older style where you would reach in and light it with a lighter or a match. A Series 200 control valve has a sealed burner chamber and a little glass viewing window that you would look through. And so they actually light with a pop starter like what you'd have on your gas grill. It's a piezo electric igniter. So this burner assembly actually has an extra orange wire on it that you would hook the pop starter up to, and you'd click it and it would spark and then create the flame inside there. You need that sealed door, you can't reach in there and ignite it. And if you take the door off, all of these components are attached to the door. So if you take the door off, you have to take apart all the components, so it doesn't work that way. One spade terminal, we're getting 13.9, 14 millivolts, a little over 14 millivolts. Because this control valve is essentially the same control valve that we were just testing on the Series 100. The same rules apply, that we're looking for 10 to 14 on the lower spade, and we're looking for at least 6 on the upper spade. On a Series 100 control valve, you can actually achieve closer to 10 millivolts on the upper spade. This particular one, you're not gonna be able to on these Series 200s because these extra wires go to a temperature safety switch that's mounted to the flame door. And so what you're gonna get is you're actually gonna get a little bit of a voltage drop across that switch. We have 12 millivolts going into the safety sensor, and we have 10 millivolts coming out of the safety sensor. We're losing some voltage just across the distance of the wires. And for reference, these gator clips did not come with this multimeter. I made these myself at a hardware store. Main reason why is it lets me be a little bit more hands-free. I can be looking at some other things while checking all of this here. Whenever you're putting your black lead on one of these front screws, you want to use the same screw every time. We're dealing with fractions of a single volt here. We're already dropping 5.5, 5.4. Sometimes you might lose your pilot light because the thermocouple goes out. Sometimes water got in there. Sometimes it was a really, really windy day. As water heaters progress, they have more safeties built into them. Each safety is consuming a little bit more voltage. That's why they transitioned away from these and went to the Series 300s. There it goes. The Series 300 is the early Honeywell or Residio gas valve with a short shank, and then the Series 400 is the same gas valve but with a longer shank because the manufacturers added insulation around the water heater. You want to pop off this bottom cover down here. We can take that cover off, and again we have very similar wires coming out of the control valve going to that safety that's on the door. So essentially there's a very tight screen on the bottom of the heater that lets air in, but it won't let flammable vapors in. A FVIR screen on the bottom of the water heater. FVIR stands for Flammable Vapor Ignition Resistant. That tight screen can get clogged with pet dander or debris or dust over time, and if the water heater doesn't breathe very well, that combustion chamber gets really hot, and that extra safety that's on the door will trip off. Now that safety that's on the door is a resettable safety. There's a little black button in the center of that safety device. The first thing we always do is we go to push that in. And if it clicks in or snaps in, then we know the thing tripped off on a thermal overload. We're gonna use a flathead screwdriver and kind of pry this little wire connector off of here. It's 2 spade terminals that go into the front of the unit. And you just gotta be careful. If it takes a couple extra seconds to pull it off, it's fine. The last thing you wanna do is break that connector. And you notice you got a red wire and a white wire. It doesn't really make a difference, but I always take my red prong and I stick it in the red wire side, and then I take my black prong and I stick it in the white wire side. We're just gonna leave those prongs in there, and they just kind of sit in there and hold in there with friction. And now we're gonna relight the heater. Now, because this connector is not connected to the gas valve, the voltages that we're gonna be reading here, those voltages are not gonna flow through to the gas valve. So the only way that this works is we have to hold this pilot button open. And we're gonna light the unit, and we're gonna watch as the thermal pile that's inside there starts to heat up. What we're gonna start seeing is climbing voltage. So right now we're at 27 millivolts, 28 millivolts, 29, 30. It's gonna keep climbing. The number that we're looking for is actually a minimum of 350 millivolts. Right now we are at 437, 445, it's still going. We have so many millivolts. Now we're actually measuring in whole volts. We're 0.52 volts right now. That's 545 millivolts. That number will keep climbing and keep climbing and keep climbing. If this water heater was giving us trouble and it was not staying lit, or it was going out all the time, the first thing we do is make sure that thermal reset button is not popped out. The next thing we do is we make sure that the FVIR screen on the bottom of the heater is very clean. This particular unit does not have a thermocouple in it. It actually has a thermal pile, and a thermal pile produces a lot more voltage than a thermocouple. Thermocouple, 30 thousandths of a volt. A thermal pile is gonna be like 600 thousandths of a volt. We are at 641 millivolts. The make or break rule with testing a thermal pile or a gas valve is on this unit here, we need 350 millivolts minimum. If we're getting at least 350 millivolts performing this test, then our thermal pile is perfectly fine. We need to replace our control valve. If we have a water heater that's going out all the time and it has this series 300 or 400 control valve on it, and we're getting less than 350 millivolts performing this exact test, then our control valve may or may not be okay, but we do need to replace the thermal pile. I've been doing this a long time. I think I've only ever had to replace one thermal pile in my history as a plumber. The thermal piles are very durable. Most likely it's a control valve issue. These are very similar control valves to what you would find on box store units. Box store water heaters are completely different than standard water heaters. They look similar. The control valves even look similar. It's the same outer case. The inside of the control valve is completely different. However, it does test the same. We're looking for that 350 millivolts. So I'm gonna pull my leads out of here. And the moment I plug this back into the front of the heater, this status light is gonna start blinking. Now it's blinking, and the moment that status light blinks, I can now let go of this pilot button, and then I can turn it to the temperature that it needs to be at. You're not gonna be able to walk into a plumbing supply store and order a Series 200 gas valve. Most supply stores don't understand the series relations with that. Most of the time when you walk into a plumbing supply store, they're gonna wanna get your model number and serial number of your water heater, and that way they make sure they order the correct unit. If you are looking for where your model and serial number for your water heater might be, you're gonna look on your heater, and there's going to be a sticker similar to this. Sometimes these stickers are a white sticker. Sometimes these stickers are a clear sticker with black writing on them. This is where we get our series numbers from. GS650 BRT 400. If this video's raised any questions for you or anything like that, feel free to drop a question in the comments. We would love to answer that for you. Hopefully this video gave you a look into plumbing in a way that you've never seen it before. That's the whole goal with our channel, is to give you the most professional view into what we encounter every day as plumbers. Until next time, we will see you later. If you've never cooked hot dogs on a water heater burner, you ain't living. It's melting the protective coating on the end of this. This is in a tank of water. It's not exposed to the open flame, so that's That's kind of funny. So the other funny thing is we pulled these parts out of our standard inventory, and they'll go back in our standard inventory when we're done. Somebody's going to get a new water heater gas valve or water heater burner assembly.
Yeah.
And be like, why does it smell like Oscar Mayer wieners every time I turn my heater on? I don't know how to tell when a hot dog's done cooking.
I mean, they look like they're done.
I mean, they're charred. I don't know what their internal temperature is. It's got a nice ballpark, oaky finish.
Oaky afterbirth.
After birth.
Little extra char on there.
Yeah.